Hello, I am Dr. Uksun Kim. In this video, we will be discussing the parallel axis theorem and moment of inertia for composite areas. This slide shows the overview of my lecture. In the beginning, I will talk about the moment of inertia for basic areas and parallel axis theorem. Then I will give applications to show the usefulness of parallel axis theorem. Next, you will learn about the steps for calculating the moment of inertia for composite areas. After these slides, I will solve two example problems with detailed explanations. Finally, I will provide a practice problem to check the level of your understanding related to this topic. This slide provides the moment of inertia for basic areas. The moment of inertia of basic areas can be found from the following figure. And then also you can find from the most textbook for static. So this is the moment of inertia for rectangular area, triangular area, semicircular area, and quarter circle area. Moment of inertia of rectangular area, there's a BH cube divided by 12. This one is worth to memorize. This slide shows the parallel axis theorem and then also equations for this theorem. When the coordinate system are parallel, in this case, x and x prime, the y and y prime, that is the parallel. The desired moment of inertia can be obtained by using the parallel axis theorem. So here is the equation for the parallel axis theorem. So for the Ix, that means that you want to find the moment of inertia about x-axis. In the case Ix prime, that means that the moment of inertia about the centroidal axis x prime plus area A and then dy. That is the distance between these two axes, x and x prime square. That is you can find the moment of inertia about the x-axis. Okay, so you can find this value using these two equations for the Ix and Iy. This slide gives applications. So cross-sectional areas of structural members are usually made of simple shapes of combination of simple shapes. To design these types of members, the moment of inertia should be found, especially for the beam design, like a T-shape or wide flange shape. This slide provides a step-by-step procedure to calculate the moment of inertia of composite areas. Step 1 is to divide the body into pieces that are known shapes. Step 2 is to locate the centroid of each part and indicate the perpendicular distance from each centroid to the desired reference axis. Step 3 is to determine the moment of inertia of each known shaped part about the desired reference axis using the parallel axis theorem. Step 4 is to add the individual moment of inertia obtained in step 3 to determine the moment of inertia of the entire area about the reference axis. It is a good idea to make a table related to steps 2 through 4. This slide shows an example problem 1. We need to determine the moment of inertia for the rectangular area with respect to the axis xb passing through the base of rectangle using the parallel axis theorem. So that is the xb, okay? So your first one is to find the ix prime. So that one is to relate to the moment of inertia about centroidal axis x prime. And this is a rectangular case. You know that there's a, I recommend to memorize it, but the bh cube divided by 12. And then using the parallel axis theorem, you need to find the moment of inertia about xb. This slide shows the solution of example problem 1. So the moment of inertia about the xb axis, there's a ix prime, there's about the centroidal axis x prime plus a dy squared. So that one, the bh cube divided by 12. So that one is the ix prime plus area of this rectangle, there's a bh, and then distance from the xb and x prime between these two parallel axes, there's a h over 2. So there's a h over 2 square, right? So that one is this one, right? So there's a h square over 4, right? So that one is the bh. So you have this one. So you add it, and then you will get the bh cube of 3. So that is the moment of inertia about xb. This slide shows an example problem 2. So we need to determine the moment of inertia for the cross-section of a wide flange beam with respect to the centroidal axis x prime. So this problem, the centroidal x prime is in the middle because this is due to symmetry. So that one is at the 6 inches. And then also this one is the 6 inches, right? So to find this one, first step is that divide into segment and fill in the table. I will show the next slide. And find the ix prime of this wide flange beam using the parallel axis theorem. So now let's try to solve this problem. So first step, divide the segments. So there's a 1 and 2 and 3. Okay. And then first thing is to find the area for the 1. So there's a 4 times, right? And then 20, right? And then 2 is the 12 times 4. And then finally 3 is the same. So there's a 4 times 20, right? So this is the value. The dy. So dy is that you can see that the 1 is at the centroid is in the middle here, right? So that one is at the centroid of this part, and this one is at the here, and this part 2 is at the here. So the distance between the two axes, the second one is at the 6 inches, this one plus 2 inches because this is in the middle. So that is at the 6 plus 2. That is the 8. Okay. And then part 2 is a 0. And then part 3 is it the same as 8? If you can write down the negative 8, that's okay, because it'll be squared, so it's the same. And then Ix value. So Ix value of the individual segment, that one is also 1 over 12, right? The B is at the 20, and then H is at the 4 cube, BH cube, right? And then 1 over 12, B is at the 4, and then h is the 12 cube. And then this one is the same, the 12, 24 cube. And then the next step is to find the related moment of inertia about x prime with this equation. So Ix, this value, plus a dy square. So with this one, you can find the 5,226.7 inches to the fourth power, right? And then this one is the a dy square, but this is dy is 0, so this value only. So this is 576. And then bottom one is the part 3 is the same. So your I x prime value is at the 5226.7 plus 576 plus 5226.7. So your final answer is at the 11,029.4 inch to the fourth power. So that is the solution for this. This slide shows the practice problem. This problem is asked to determine the centroid for the cross-sectional area of the T-beam and then find the moment of inertia about the centroidal axis x prime. So you can see that this is T-beam. First thing, you need to find the central location. Because of that part of it, you can find the location of the x bar. You can find it. The first step is to find the centroid. And then to solve this problem, you need to divide into segments and then fill in the table for centroid and determine the centroid. After finding the location of centroid, you can calculate the moment of inertia about x prime. So that is the procedure. So find the divider into segment, determine the y prime, the centroid location, and then after that, you can find the moment inertia, the Ix prime, using the parallel axis theorem. And then next slide shows the tables to fill out to help to solve this problem. Okay, so this table is for the first one is that the solve for the centroid, and the second table B, that is for the solve for the moment of inertia. I hope this video will be helpful for you.